starting with our basic arithmetic. Now question 1, it says round off this number to the nearest 10. Nearest 10, we're looking at the last 2 digits, so you can see that's 89. 89 is closer to 80 or 90? Well, it's closer to 90, so we simply say 1,290. Okay, so you always look at the last 2 digits. Now B, round off this one to the nearest 100. So it's the same number, but we look at the last 3 digits, yeah? So 289, is that closer to 300 or 200? It's definitely going to be 300, so we write our answer like this. Okay? Now round off the same number to the nearest 1,000. So we'll look at the whole number and we ask ourselves, is it closer to 1,000 or 2,000? Hopefully you guys can all answer that it's closer to 1,000, so that's the answer to the nearest 1,000. Okay, so it's a very easy question. Question 2, write 876 to the nearest 10. So again, we look at the last 2 numbers, 76. Is that closer to 70 or 80? Hopefully all of you said 80 because the answer is 880. Okay? Write the same number to the nearest 100. Again, 876. Is it closer to 800 or 900? Must be closer to 900. And the same number to the nearest 1,000. Well, is it closer to 0 or 1,000? Because that's what it's between. It must be 1,000. So its nearest 1,000 is 1,000. Question 3, write the following in scientific notation. Hopefully a lot of you have heard of this before. Scientific notation is what we use to write big numbers or really small numbers into a simplified form. So you can see that this number is quite large, isn't it? So it's a bit annoying to write and it's a bit too big to write or say, isn't it? So what we can say is we can change it to a decimal number and trying to use multiples of 10. So you can see with scientific notation, we always like to put the decimal, in front of the first non-zero number. So see how the first number is 1 and I can ensure that that's not 0. So what I'm going to do is put a decimal in front of it like that. Okay, but the decimal on the original number is here, isn't it? The decimal number is there, so what we do is we go 1, 2, 3, 4, 5, 6. We have to multiply by 6 times of 100 to get back to the original spot. So this part will become 10 to the power of 6, yeah? And then it says 3 significant figures, so this number here, can we round it to 3 significant figures? Well, it's already in 3 significant figures, so we simply say 1.43 times 10 to the power of 6, as I've said. Okay, so always trying to put the decimal in front of the first non-zero number and trying to count, use your fingers, and see how many times we have to go back to the original spot. Okay, and always consider the rounding off part that they ask us to do. Now B, 2 significant figures, and you can see this is a very small number, it's very close to 0. But again, I want to put the decimal in front of the first non-zero number, and these are all 0. The first non-zero number is 6. So what I'm going to do is put the decimal there, okay? But the original decimal point is there. So how do we get back to the original spot? This time we have to go backwards. So we're going to go 1, 2, 3, 4, 5 places backwards. So it's basically moving back 10 5 times. So it's going to be 6.5 times 10 to the power of negative 5 because we're going backwards. Whenever we're going backwards, we put a negative in front of the index. And it says 2 significant figures, but it's already in 2 significant figures, so that's the answer. So question 4, we can convert each percentage to a fraction in its simplest form. Now, we know that percentage, this symbol here, means over 100. So what I'm going to do is simply put that over 100. So replace that sign with that fraction. And I don't want a decimal on top of a fraction. That's not very clear, that's not precise. So what I'm going to do is to get rid of the decimal, multiply by 10. Because if I multiply by 10, that decimal will move 1 place to the right, which makes it no longer a decimal. So make sure you do the same thing to the denominator as well. If you do something to the top, you must do the same thing to the denominator. So that becomes a 1 and this becomes 1,000 because 100 times 10 is 1,000. Okay, and that's pretty much it. Hopefully the last bit was understandable. Now B, we do the exact same thing. So hopefully guys, you can do this on your own. Again, replace that percentage sign with over 100, it's a fraction over 100, and we don't want the decimal, so simply multiply top and bottom by 10 again to get rid of that decimal. So now it's a nice fraction, but make sure you simplify by the common factor, which is going to be 3 on 8. Okay, so make sure you can do your simplification. Now question 5, this time we want to increase 350 by 15%. When I increase, guys, we're going to be extending 100%. We're going to be over increasing 100% because the 100% is your original price or your original value. But when we go 15% increase, we're basically going 115%. Okay, so say for example, if we're going different direction, if we're decreasing, that means we'll be doing 85%. So always treat 100% as your original value. So what I'm going to do is multiply 350 by 100 plus 15%, as I've said here, because we're increasing. So it's going to be 115%, as I've said, isn't it? And then you simply calculate that. Maybe you can use your calculator or change it into a decimal like I did first, and then get your answer. Okay, if you have a calculator handy, you can just insert it into the calculator and get the answer straight away. But the key thing here is this part here. You have to multiply by 115%. I know a lot of people like to calculate 15% of that first and then add it again to 350. That's perfectly fine, but this way is a lot more precise and quicker. Okay, so I want you to try to get into the habit of using this method. So that was 15 when we're increasing. 6. The cost of a calculator is now $32. If it has increased by 3.5%, how much was the old cost? So old cost is the original cost. Okay, so this price is the price that has been increased. Okay, so the old cost must have been smaller. And it increased by 3.5%, haven't it? So if 100% was the original price, so the old cost, if it's increased by 3.5%, this one must be 100 plus 3.5%, which is 103.5%. So that value is 103.5%. The old cost is representing 100%. Just keep that in mind, okay? So what I'm going to do is let x be the old price. I'm going to use a bit of algebra because that always helps me solve the problem. So if x is the old price and this is the new price, remember how I said this is 103.5%. So x times 103.5% is 32. Okay, so this is just 103.5% as a decimal. So you can write it as a fraction or whatever you like, as long as it makes sense. So to get x, we simply need to divide. So divide 32 by the 103.5%. Calculate that, you should get something like this. It's a price, so we might as well round it to 2 decimal places. So it's $30.92, okay, to the nearest cent. Does that make sense, guys? So because you're just simply multiplying by that, you don't have to go and do multiple steps. You can just get that in one whole step. Okay? Question 7, express as simple fractions. So we've got 0.25. Guys, I think everyone or most of you should know that 0.25 is 25 over 100, isn't it? And we can simplify that by the common factor of 5. So divide top and bottom by 5, or 25 actually in total, because both can go into 25. So you can use multiple steps if you like, if you can't think of the bigger factor, but if you can, maybe divide by the highest common factor. Okay, so that's pretty much all there is. Make sure you know that that is this. Now B, okay, we've got some division of fractions, so make sure you simplify it first and then trying to calculate it. So when we divide fractions, we can always change it to a multiplication by flipping the second fraction, can't we? So change it into a multiplication and flip the second fraction like that. And then you can do multiplication. So 5 times 5, the 25. 8 times 4, 32. And make sure you keep that negative in front. All right? And we don't have any more common factors, so you can just leave it the way it is. Let's do another one. Okay, we've got some mixed fractions now. Whenever you have mixed fractions, I always want you to change it back to improper fractions. In that way, we can do whatever we did in B and A, so we can make it a lot more simple. So first of all, let's change it to improper fractions, like this. So make sure that hopefully you got learnt from your junior years how to do this, but for those who forgot, let me refresh your memory. 5, the denominator stays the same, and on the top, you multiply these two numbers together, so 4 and 5 together, and then you add whatever's on the numerator. Same for here, you leave the denominator, and for the numerator, you simply multiply 1 and 4 together and add on your 3. Okay, and that's your answer. So simplify that one, make sure you do the multiplication first, and you should get something like this. Okay, and then make sure when we want to merge those two together, when we want to do the subtraction, we have to make a common denominator. So trying to find your lowest common multiple of 5 and 4. I think it's going to be 20. So that's what I'm going to be doing. So 5 times 4 makes 20, doesn't it? So the denominator is 5 times 4, which will ultimately be 20. And we have to multiply this fraction by 4 and this fraction by 5, don't we? So 23 times 4 on this side and 7 times 5 on here. Trying to simplify each denominator and numerator, and you should get something like this. See if you can simplify further and make it back into a mixed fraction. Because the question is in mixed, I want you to leave the answer in mixed as well. That makes it a lot more precise. Okay? And that concludes the arithmetic section.